Hi guys, welcome to this page of the notes. Again, what we're doing is we're graphing radical functions, and now we're beginning to take a look at how you do that using transformations. So let's just jump right into that. We know that our general formula, I had it on the previous page, I'll write it here on this one for you, is this: y equals plus or minus a times the square root of x plus or minus h plus or minus k. Right? That's my general transformation equation for the parent function of a radical, or the square root function. And so now I can pretty easily tell that I have an a that is equal to a -2. That tells me two things. First, that tells me that my radical is going to open down underneath of the x-axis. It also tells me, since 2 is greater than 1, I'm going to have a vertical stretch, which means that my radical function is going to be a little bit deeper, right? That slope, that arc is going to be much steeper. H is a +3. That means that my starting point is going to shift 3 units to the left in the negative direction. And K is equal to a -1, which means my starting point is going to shift 1 unit down. So here we go. Let's go ahead and find that starting point. +3, which means I go -3, 1, 2, 3, and -1 means I go down 1. And so I already know I'm going to start right here at -3, -1. Now, to find the rest of the points to graph, we still are going to need a table, and we're still going to work smarter, not harder, but I already know -3, -1 is my starting point, thanks to those transformations. I also already know that my graph is going to head in this direction. It's going to open down thanks to the negative, and it's going to be kind of a steep opening down because of that vertical stretch, a being a +2. Anyway, let's jump right into this and see if we can find some other points that are not decimals. We want integer points, and we do that by using the perfect squares, right? Working smarter, not harder. All right, my next perfect square, right? Well, I've already done the perfect square where I would get 0. If I plug a -3 in, -3 plus 3 is 0. Square root of 0 is 0. 0 times -2 is still a 0. And 0 minus 1 is -1, right? So this was by using the perfect square of 0. My next one is 1. So I need to figure out how to make x plus 3 equal to 1. Well, you guys can probably pretty easily tell you're going to do a -2. If I plug in a -2, -2 plus 3 is 1. The square root of 1 is 1. 1 times a -2 is a -2, and -2 plus a -1 is -3. So my next point is going to be -2, -3. My next perfect square is 4. So I need to figure out how to get a 4 in there. Guys, again, should be able to tell pretty easily I need to use a +1. 1 plus 3 is 4. Square root of 4 is 2. 2 times a -2 is a -4. -4 plus -1 would be -5. My next perfect square is 9. How do I get a 9 in there? Again, you should be pretty easy to tell it's going to be a 6. 6 plus 3 is 9. Square root of 9 is 3. 3 times a -2 is a -6. -1, -7. Let's just check and see. I think that's all that's going to fit, but my next perfect square after 9 would be 16. How do I get a 16 in there? Well, I'm going to need to use a 13, and actually we're going to stop, right? Because 13 is way off my graph. I can fudge an 11, but 13 is way out there. So those are all the points I can do. Let's plot them and draw our graph. -2, -3 is my next one. -2, 1, 2, 3. 1, -5 is my next one. -1, -2, -3, -4, -5. And 6, -7. Right down there. Go ahead and connect those points with a smooth curve. That is my starting point. It'll just continue off in that direction. So I'm going to put my arrow over here on that side of it so that I know you know that that guy just keeps going. There's my starting point. It's no surprise it opens down. A is negative. And it's no surprise that it looks like it's a little down. It's a little deeper arc because I have a vertical stretch. A is 2. All right, guys, that takes care of these problems where we're graphing functions that have a radical in them. On the next page of notes, we're going to see how these functions actually apply in some word problems. So head on over to the next page of the notes, and I'll meet you guys there.